Hello, everyone. Welcome to day 2 of CCIP Bootcamp. My name is Andre, and I'm going to be your instructor today. As you already know, feel free to drop in a chat where you're tuning from which country or city, and we are going to start with that. So this is just a quick checkout for me, so I know that you can hear me, clearly see me, etc. Also, if you have any questions from yesterday, feel free to drop them in a chat as well, so I can start with answering those. So we have people from states, if I say that correctly, that's the US vibe. So welcome everyone. Good morning, good evening, good afternoon. Hi from Argentina, that's great. Yeah, so if you have any questions, feel free to drop them in the chat while I'm sharing my screen. Let's do this. India and Russia. Hello, good morning, everyone, or actually good afternoon. So we're gonna do just this window. Okay, cool. You should be able to see my Twitter. So tell me, my name is Andre. I'm one of the developer relations engineer here at Chainlink Labs. And I tweeted this yesterday because these were a couple of the most common questions asked about homework. So I'm going to repeat those. So you have homework assignments after each day. You will need to score at least 80% of correct answers in order to earn a certification of completion to the bootcamp. We are gonna review, we as developer relations engineer at Chainlink Labs are gonna review those assignments afterwards. The deadline is August 25th, so we have like 19-ish days to finish. And day 1 consists of theory questions, 5 easy, 5 medium, 5 hards. And then for day 2 and day 3, you will have coding assignments. So for that, it's advisable to have a GitHub profile set up because we will ask you to provide a URL to a public GitHub repo, which we can git clone and see and validate that you completed the homework correctly. So where this is coming all from? Well, from our Gitbook. So cll-devel.gitbook.io/ccip-bootcamp is the Gitbook that we're going to use throughout all of these 3 days. And this is the page where you can find the homework for day 1 and also the URL to the Typeform where you can submit your answers. I'm pretty sure Typeform will keep your answers while you are in the tab, like because of the cache memory or whatever, but don't rely on that. Just have a separate doc where you're gonna, or markdown file or whatever, where you're gonna have all your answers ready while you're studying and just copy paste them once you're ready to the Typeform. Questions are not that hard at all. All the answers you can find either in Gitbooks or official Chainlink documentations or both. But it's important to learn in this manner because after you complete this bootcamp, you'll be 100% ready to put CCIP as a skill in your resume. Trust me. We have also a lot of newcomers, so new faces joined our bootcamp for day 2. So for the ones who missed day 1, you can subscribe to the Chainlink official YouTube channel, just Chainlink on YouTube. And here you can find the replay of the yesterday's talk. This video will also be available on demand right after we end this live stream, so you can rewatch it at your own pace, and same goes for the day 3 tomorrow. Also, a couple of you have had issues with faucets yesterday because we kind of spam our Chainlink faucet. So the official faucet is the Chainlink URL, but also there is this bootcamp faucet. So if the official faucet the chain.link does not work, you can click on this one and just enter the Big Mac 777 password, and you will see this page where you can connect your wallet and grab some more testnet faucets. For today, we're going to need arbitrary Sepolia, ETH, and Link. So make sure to have those. And for tomorrow, for day 3, you will need Avalanche USDC on Avalanche Fuji. So again, this is the URL for the public circle faucet. So Avalanche Fuji USDC, put your wallet address, you can get 10 USDC. Easy, like do that now or later or whatever. You also need this for the transporter exercise from day one as well, but you will definitely need it for tomorrow to do that. Or if that doesn't work, like if we spam that faucet, you will already always have the option here to go to Avalanche Fuji and select USDC from here. So that'll be it. A couple of stuff that for the new people that join us and haven't seen the class from yesterday. So we have SmartCon. It's happening in late October in Hong Kong. This is a conference where TradFi will meet DeFi basically. So you can register here, clicking on this URL or scanning this QR code. We have a lot of stuff there. Besides the main conference, like the main event, 2 days before, we'll have a Hacker House, which is a specially crafted event for developers like you. And this is just some of the past SmartCon speakers, like a lot of familiar faces from DeFi, TradFi, and big tech in general. So you don't want to miss that. Also, we have this bootcamp, tokenized RWA bootcamp. This bootcamp is not live yet. This is just a preview for you guys. We're gonna promote it later this month, but right now you can sign up and be notified about all the prerequisites needed and about the actual start dates, which is September 30 to October 2nd. I'll be one of the instructors for that bootcamp as well. And it's going to be intermediate level at least. So we're going to use Chainlink services, multiple Chainlink services like functions, CCIP, automation, data feeds, proof of reserve feeds, etc., to tokenize a house, making NFT out of it, like real world asset. And then we'll use that tokenized asset to get a loan and get some USDC in return, or fractionalize it and then sell a portion of it to whoever, earning yield, etc., etc. So a lot of interesting use cases can come up out of this one. So again, you can register either here or by scanning the QR code. And yeah, that'll be it for today. Let's see what we have. Where is the agenda for today? So this is the certificate of completion that you will get if you finish your homeworks. 80% of correct answers, of course. So for day two, we have a little bit of theory. We're going to talk about CCP architecture, deep dive into it. So yesterday, Richard went to the basic CCP architecture with you guys. And now I'm going to deep dive into it to see all the tiny details that is happening under the hood when you send a cross-chain message. Then we're going to talk about how we can design cross-chain NFTs. And then we're going to create the fully functional cross-chain NFT project. So not a project that you can just, not a contract that you can just cross-chain mint an NFT, but actual cross-chain burn and mint NFT smart contract that you can use on testnets. And then we are kind of going to learn how we can test everything with CCIP using Chainlink Local, our Chainlink Local simulator. And this will hopefully end all the issues with testnets, faucets, getting this token, that token, gas spikes, all that stuff, because I'm going to teach you how you can build locally much faster in Foundry, Hardhat, or Remix. You'll have your homework will be actually assignment on Chainlink Local. And then once you're ready, then you can move to testnets, because testnets are for testing and local environment is for building, logically. So that's why we created Chainlink Local. Finally, we're going to talk a bit more about debugging tips and tricks. This is more like a guide for you to help you to debug stuff when you're doing stuff on testnets directly with CCIP, because, okay, going through bootcamp material, copy pasting, following instructions are great, but then you'll naturally want to do something by yourself. And then if you're not using Chainlink Local that can easily spot up all of those errors in a local environment, then you can use some of these tips and tricks. And finally, we'll have a guest lecture. We'll have a talk with a Celo team. Like a preview, we'll have Sophia joining us. She's the developer relations engineering lead and really fluent with cross-chain stuff and CCIP in general. So we can start now. Well, before we start, let me see if we have any notable questions down in the chat. Hello, guys from Indonesia, Mexico, and UK. Yeah, we also have Richard Godlieber and Zubin Pratap in background answering all the questions. Hi from Nigeria. They can also help with questions. We have 2 questions. Could we please have those faucet details in the chat? And they're asking for visitor password. Once again, this is your Gitbook. Everything is here. If you go to setup instructions at the beginning, click on the URL. This is the URL for the Bootcamp faucet, and this is the password Big Mac 777. Just enter that, and that's it. Okay, cool. That's pretty much it. Okay, we can start with day 2. Cool. As a refresher, that'll be, I think, at this page. Yeah, this is the basic CCP architecture. It's like a black box. So you have a one CCP router contract per CCP supported blockchain, and that router contract handles all the routing of cross-chain messages you send using CCIP. And then in between, we have this CCIP thing, kind of as a black box that can send messages, and message can contain data, tokens, or both. And that's pretty much it. Today, we're going to start by explaining what's inside this black box. So if you click on the CCP day 2 architecture, message, and processing, this is the larger schema or architecture of the Chainlink CCIP. So you can see here that, again, we have end users on both sides, on both blockchains, and sender and receiver contracts if needed on both blockchains. And from going from left to right, we have a sender that first need to prepare a message to send. So message is type EVM to any message in Solidity, meaning that we are sending from an EVM-based blockchain to any blockchain. Literally any blockchain. Can be another EVM blockchain, non-EVM blockchain, I don't know, like private chain, bank chain, Polkadot, Solana, Bitcoin, whatever. Like it's designed to support any blockchain in existence, right? So that's why we're sending EVM to any message. And EVM to any message is just an struct in Solidity that contains the following information. So the receiver address, but in bytes. Then data payload, data you're sending, also in bytes. Token and amount you're sending, so token address and amount you want to send is like another Solidity struct. Address of a fee token, if you pass the link address, you're going to pay for CCP fees in link, that's cheaper. Or if you put address 0, that means that you're going to pay in native coins. So that means that you can use message.value, for example. On Ethereum Sepolia, that can be Ether, right? That'll be under the hood converted to wrapped Ether, and etc., etc. And finally, there are some additional parameters, extra args, where you can set gas limit to whatever value. So empty quotes means that gas limit is set to 2,100 by default, 200,000 by default, but you can set it to up to 2.5 million, or also 0, because if you're sending just tokens to the external owned account, you should set it to 0. Why? This gas limit is the gas that's gonna be used to call the CCIP receive function on the other side, and it is non-refundable. So that's why you wanna set it properly. And actually in day 3 homework, you're gonna deal with all that, so be patient. Cool, then why everything is bytes? Because CCIP is blockchain agnostic, everything not be converted to bytes. So ABI encode, ABI decode on both sides, we'll see that in the code. That's something that you should be fluent with after you finish this bootcamp. So, okay, message processing. We here have on the left side, you should be able to see my pointer over here. So we prepared a message object that can contain data, tokens, or both. And we're calling the CCIP send function of the router contract over here. And we're passing 2 parameters, the message object and the destination chain selector. Destination chain selector is the unique ID of the CCIP supported blockchain. And it's not the same as chain ID. For example, on Ethereum mainnet, chain ID is 1, Ethereum Sepolia, chain ID is 111551111, but chain selectors are different values. And you can find all these values in the official Chainlink documentation. And you should always, always, always go to docs.chain.link. This is the official docs where you can find all the latest info about CCIP. This kind of answers one of your questions from homework from day 1, by the way. What's the difference between chain selector and chain ID? Cool. using that info, router will know which lane, CCP lane to take and pass the message. Then we have on-ramp contract over here, which is basically a contract that can interact with token pools. Token pools are another set of smart contracts that holds basically tokens. And if you're sending tokens, there are three sending mechanisms: burn and mint, burn and lock, and mint and unlock on the other side, and lock and unlock. I'm not going to talk too much about token mechanisms. You can read about them in the docs or in the masterclass number 1. But the thing is that if you're sending tokens, on-ramp contract will interact with the token pool contract. And also for token pools, for extra security measures, there is a nice pattern called rate limits or rate limiting, which again, you can read about it in the docs. And I'm also planning to write a blog post for my smart contract design patterns newsletter about that pattern. So it's really, really cool, really clever solution, and really secure solution. So I encourage you to check that later, because that's one of the hard questions actually for the homework. On-ramp contract finally will emit some events. A specific event that's going to be emit is that a new CCP message has been requested or transmitted. In the middle, we have three offchain components, three DONs. DON stands for decentralized Oracle network, and it consists of different type of node operators that do different type of jobs, and then they will meet to reach a consensus of certain actions, and these three DONs power the off-chain part of Chainlink CCIP. So committing DON will listen to all the events coming from the on-ramp contract, as we can see on this with this arrow. The thing is that when you're sending CCIP messages, you basically do not send like message per message. We basically send like transfer a batch of all cross-chain messages from one blockchain to another. And how? Because we're gonna, okay, this is a new cross-chain message. We're gonna wait for a finality tag. So that's really important security concept. Like finality generally in blockchains is really important, because you don't want your transaction to end up on a canonical fork, on like a fork that is not part of the main chain eventually. So for example, on Ethereum, you need to wait for 2 epochs to reach finality, and that's like up with proof after the merge with proof of stake, and that's like the time that we need to wait to make sure that our transaction will stay and end up on the actual main chain. So committing DON will just notice your cross-chain transaction and just bundle it up with other cross-chain transactions in that 2 epochs period or until the finality, and then recreate Merkle tree with all of these transactions. So what is Merkle tree? If I scroll down a bit, so this is what Merkle tree looks like in computer science in general. It's kind of like inverse tree in nature. So the root is on top and the leaves are on bottom. So we have all these leaves. Leaves are essentially cross-chain transactions, like cross-chain messages you're sending using the CCIP. And the thing is that you can create a hashes of these leaves. So hash, like we have like as leaves M1, M2, M3, and M4, 4 different messages, and then each of M1 is basically a hash of message 1, hash of message 2, etc., etc. So hash is just a fixed series of characters and numbers, which are like a product of a hashing function of your input. And the thing is that you cannot get the actual message in reverse from the hash. That's why it's powerful. I'm pretty sure you already know that, because that's what is one of the core primitives of all the modern blockchains today. So actually, we're gonna recreate the whole tree with this root hash, and only root hash, not we, but nodes in a committing DON will recreate these trees, and only root hash will be reported to other nodes. Now, all the nodes in the DON talk to each other using peer-to-peer network, calling off-chain computation, OCR, like that's the algorithm, to reach a consensus on the actual root hash. Like they're gonna basically exchange their root hashes and compare it and vote to reach a consensus. And then I'm gonna just go back. Then there is on the source blockchain, just over here, a contract that you can see called commit store.sl. The transmitter node from the DON will transmit that hash to the commit store smart contract. Now, risk management network, another offchain component, another DON with the same node spec, but the client written in different language. So risk management network client, node client is written in Rust, committing and executing DON clients are written in Go, but using the same specs. This is just another security measurement. So we can see from the screen that from the picture that risk management network also listens to the on-ramp contract from events. It basically do the same thing, like recreating all the cross-chain messages in a tree. But after that, risk management network also listens to the commit store smart contract over here, and then each node in this DON will compare the hash they calculated with the hash reported by the committing DON on the commit store, and then vote whether the status is blessed or cursed. So blessed means good, continue with transfer of cross-chain message. Cursed means stop with the cross-chain message sending. So all of these nodes will basically vote, and they have like weights. And the thing is that they can vote multiple times, like multiple blesses, but once they want vote for curse one, that's it. Like that's their final vote, essentially. So cursed, we don't want to see. There is a recovery protocol for that. But if you see a blessed status in your CCP, the chain.link page, this is the CCP block explorer we used yesterday, and we're going to use it today. If you see blessed status, that's good. That means that the message will arrive. So the common status is like waiting for finality, source finalized, and then you're looking for blessed. And after that, it's either success or failure, hopefully success. If it's failure, I'm going to show you how you can debug it to make it success. Cool. Once we have blessed status over here, on the reported to the off-ramp contract, the off-ramp contract will emit an event, and executing DON will listen for that event and catch it as a signal to continue with the delivery of cross-chain message. And now executing DON will just, one of the nodes from the transmitter DON, from this DON, will just continue with delivery of that batch of cross-chain messages. Again, if there is some token sent, then off-ramp contract will interact with the respective token pools. So for each token, one token pool, and finally call the router smart contract, which will deliver the message. How? So if it comes to tokens, it'll just transfer tokens to the receiver. And if there is data to be transferred, then router contract will try to call the CCP receive function on your smart contract. So if you're receiving data, you must implement CCP receive function. If you're not receiving data, just tokens, then you don't need to implement anything at all. Cool. Any questions about this part? That's pretty much it, Okay, cool. Cool. There was two questions about risk management network. Is risk management network related to zero knowledge proof? No. We're not using zero knowledge proofs with risk management network, to my knowledge. We're using it for data streams, though, but that's another topic for tokenized Bootcamp. But for this one, no, they're literally gonna just calculate the root hash of all these transactions and then compare it locally, and then report those votes, reach a consensus vote. Votes can be weighted as well. That's another security measure, and that's it. Risk management network is the consensus layer for CCIP. Kinda. You can look at it like this. It's more like a layer that monitors committing and executing DON and make sure that there is no like issues or bug in those steps. Like it's basically overlays the whole process, and make sure that everything is like smooth and steady. Okay. Another question, is each message treated like an independent block in the context of or batch like other blockchains? Okay, I think I understood this question. So essentially, from your user perspective of you, this is sending a cross-chain message is a 2-transaction process. We'll see that on an Explorer. So one transaction is on a source blockchain that will call the router contract to the CCP send function to the router contract, and that transaction will emit a bunch of events that will trigger offchain components. And then the second part is like another transaction by the router contract on the other side, and actually by the transmitter DON from the emitting DON through the router contract on the other side. And basically in that second transaction, your messages will arrive. You don't care generally about other messages, but yeah, like we'll try to batch them like in a block if possible. Okay, cool. No more questions. So I think we can proceed with theory. Just a little bit of theory, not too much. Is basically, do you need to care about all of this? Well, yes and no. Like your mental model can be to actually see CCIP as an like international flight, right? So like when you go to the international flight, one of the first stuff that you're going to do is they are going to check your luggage, and then your luggage will do a lot of stuff actually they will do a lot of stuff with your luggage in the background. You won't see that. You're just gonna take a quick coffee, or like take a walk to your terminal, have a nice flight, etc. Go through immigration, and finally on the other side, if you're traveling to Hong Kong, for example, or SmartCon from JFK, you're gonna collect your luggage, right? And you can see like a note that your luggage has been opened or not, or whatever. They will definitely gonna scan it, do all that stuff for you, but you don't see it, right? The same thing goes with CCIP messages, right? You just need to take care and be aware of that basic architecture that Richard showed you yesterday, like where CCIP is a black box. And like you're interacting with the router contracts, they will all gonna be always the same interface. You can make those addresses immutable. You don't care if we add a new feature or whatever to CCP later. That can be possible because like router contracts are immutable, addresses are the same, interface is all the same. So that's all good. So yeah, that's how it works. But if you want to debug something, or you have like a issue and you're not sure what's going on, then you can always refer to this material and official documentation, of course, to see what's going on in background. And depends where you're flying from, New York or Barcelona or Tokyo to Hong Kong, your flight duration will be shorter or longer. Also depends like where you're flying, to west or to east, so that same goes with CCIP duration times. Like we need to wait for the finality on the source blockchain, and that's the major driver of the speed of transaction. But of course, like 5, 10, or 15 minutes is of course much faster than to wait for 7 days, for example. Like we had situations with traditional bridges. Cool. Okay. Can you please explain the scope of processing in terms of committing and executing now? I'm gonna explain that in 30 seconds because I talk about that for like good 5 minutes. But you can find everything basically here in step 3 and step 4. So committing down will listen for the events from owner of contract, capture the cross-chain transaction, recreate a Merkle tree with all the transactions, report a hash on the committed smart contract over here. Once we have a green line, blessed status, that we can proceed with the sending of cross-chain message, and executing dawn will trigger the delivery of your transaction cross-chain message on the other side through the router smart contracts. Another question: is risk management network a Chainlink dawns or independent nodes that monitor Merkle alerts? How decentralized a risk management network is another set of Chainlink dawn. Is decentralized because node from like you cannot run node that participants in both nodes. Like one node, like all the nodes are independent from each other. So you're gonna either be a node in risk management network committing dawn or executing dawn. You cannot just overlap, and it is as simple as that. Okay, cool. Now we're gonna talk for 5 more minutes max about theory, and then we're gonna deep dive into coding. This took longer than I expected, but okay. Okay, cool. Today we're gonna build a cross-chain NFT project. So basically we're gonna create like a fully cross-chain NFT smart contract. So what is NFT? What NFTs are in general? Like NFTs are smart contracts that follows ERC-71 standard. It's basically a solid interface. So if you implement that solid interface, you technically have a smart contract that is NFT. If not, So that's why if you want to create an NFT, the most easy way is to go to OpenZeppelin, inherit their NFT smart contracts, ERC-71 smart contracts, add mint function if you want to implement by yourself, because mint function is not part of the standard. And then boom, you have an NFT. But under the hood, NFT is just a glorified hash map or mapping, because you have like a mapping of token IDs to the address of owners, and that's pretty much it. So how to make this a cross-chain project, like how to make a cross-chain NFT? Well, cross-chain transfers are not part of the standard as well. Like when standard was created, they haven't really envisioned a cross-chain vision, which is the current state of blockchain. Like singular blockchains do not scale, but if you can transfer value and data across chains fast and secure, you have like a cross-chain reality. And from your user's point of view, they're just using your dApp. They don't care usually about which blockchain they are. So how to implement a cross-chain NFT and cross-chain project, any project for that matter. So we need to have a way to avoid having double or multiple same tokens, or tokens with the same token ID present on multiple different blockchains. Like that's kind of similar analogy to double spending problem. You want to prevent, I don't know, in Bitcoin to spend one Bitcoin twice. Here we want to have only one NFT with that token ID present on that chain, one or none. We'll see why none. So imagine that you have like token ID with 777 or whatever. Like you'll need to implement one of these three mechanisms. So either burn and mint, lock and mint, or lock and unlock. For this class, we're going to implement burn and mint. So the first one, and basically that means that with burn and mint, we'll have one cross-chain NFT smart contract per blockchain. So we'll deploy cross-chain smart contract, like these smart contracts on all our blockchains, but we're going to issue it only on one chain, and that will be arbitrary Sepolia. So minting will just happen on one chain, and then you can transfer it to all other chains. How? Well, when we're going to implement mint function, okay, to issue it, then cross-chain transfer from, which is going to be same as transfer from, but with cross-chain stuff, where we're going to create a CCIP message, burn an NFT with that token ID on that chain. So we have like no owner of that token ID in existence currently, and then send a cross-chain NFT, send the CCIP message to the other side. And the other side, we have exactly the same smart contract on other blockchain with the third function implemented, which is CCIP receive. And CCIP receive will get the data field, decode it, and see, okay, I need to issue or mint this NFT to this address, the receiver, with this token ID, this is the metadata, whatever, and then I'm going to just mint it, and now the token ID, that token ID will appear on other side. Similarly, you have like lock and mint and lock and unlock. With lock and mint, you're not burning a token, you're locking it, lock inside the contract, so no owner, but the owner is like the contract itself, and then mint another one on the other side. Then on the other side, like a kind of like a synthetic version of that NFT. Sorry about that. And then when you want to transfer it to arbitrary Sepolia, for example, then that synthetic version, then you're just gonna burn it on that side and unlock it on the main chain. So kind of like you have like one cross-chain NFT smart contract on like main chain, like arbitrary Sepolia, and all the synthetic versions on other side. And the thing is that what if you have like synthetic version of Ethereum Sepolia and want to move it to Polygon Mumbai, then you can use lock and unlock, because that's just a synthetic version of like lock on this side, unlock on this side, etc. But for today, we're going to use burn and mint mechanism. And speaking of metadata, we're going to use these four characters. So Chainlink Alt, Chainlink Night, Chainlink Orc, and Chainlink Witch. We're going to implement like round robin algorithm, I guess. And that's pretty much it. Here, we'll see that I said we need a mint function, we need a cross-chain transfer from function, and we will need a CCIP receive function. Let's analyze those, actually. So mint function, we're going to do that last. It's literally like if you created any NFT with OpenZeppelin or whatever, the mint function is going to be the same. That's it. That's the gist. But cross-chain transfer from, so you have like a NFT and you want to transfer it using CCIP. So you need to provide the address from to token ID and the destination chain selector, like CCIP destination chain selector. And yeah, you're just gonna burn the token on the source blockchain and then create a CCP message like this. So receiver is the NFT address contract on the other blockchain. Data we're sending is, again, from to token ID and token URI, which we'll need also. So we can mint it on the other side. And then we're not sending any tokens. We're going to talk about extra arguments in a bit. And here we can select where you're going to pay for fees in native or link. Then when you want to receive it on the other side, we have a bunch of checks, but essentially you're going to just decode that data from the message, again, from to token ID, token URI, and just going to mint an NFT on the other side. And then there you have it. You cross-chain transfer it using burn and mint mechanism. Simple as that. What is extra arguments? That's the final thing. So we have a couple of security best practices that we're going to implement today. We're going to make to be sure to verify source chain, destination chain, sender and receiver addresses. That's crucial because we're sending cross-chain messages between these contracts. And what we want to accomplish is I want only to send cross-chain messages to the same NFT smart contract on another blockchain. I want to receive only cross-chain CCP messages from legit NFT smart contracts, the same smart contracts from other blockchains. And I want to make sure that I am aware of all chains that I'm connected to and all the sender and receiver addresses. And to do that, it's actually pretty simple. We're going to just use a couple of modifiers on a mapping. So we'll have NFT details like address of cross-chain NFT smart contract and CCP extra argument bytes. I'm going to talk about that in a minute. This is a mapping with all the chains. So destination chain selector, 2 details, and then a couple of modifiers. So only enable chain, only enable sender, and then only owner can call these functions. This is what we're going to do in a setup. So before you mint the first NFT, before you give your NFT collections, launch it to users to use it, you're going to just call enable or disable chain as an owner from the owner multisig to just connect with other NFT addresses on other blockchains, so you can have like cross-chain transfers. This is our mine implementation. You don't need to do this, right? You can just avoid all this stuff. But this is the development best practices for various different security purposes, and I highly encourage you, if you are an expert in CCIP, you have this POP, like certified medium, like intermediate to advanced stuff that you know CCIP, to always implement all of this best practices. One of these is to verify router addresses. So you always want to verify that the sender, message.sender, is the CCP router address. So you always CCP router address will be the one deliver the message, and to set gas limit. So we're going to talk about gas limit in day 3. The homework for gas limit is about day 3. But essentially, this is how you can fine-tune amount of gas that you want to spend to call the CCP receive function. And the trick is that you kind of want to do that for production contracts. Also, extra arguments fields should be mutable. Actually, must be mutable, because yesterday Richard showed you the strict value. Now, in the recent version of CCP, strict is removed. So if you have strict in your smart contract, you cannot use new versions, which is, it's not great. So what you want to do is to have like a helper contract, which can always encode arguments programmatically like this. We're going to use that. And then for extra arguments, you have like a bytes variable, which is mutable storage variable. And then again, owner multisig can update it if needed, because if CCP release some really cool feature in future, for example, I don't know, to be able to set a address, which would be the destination for a gas refund, if we implement that gas limit is unspent gas is refundable, then you kind of want to have that. So that's why you should be always make sure that extra arguments are mutable, and that's the best practice we're gonna implement today. Cool. Let's see. Question: Does same concerns apply with _safe min for ERC721 cross-chain? This smart contract does not implement ERC7 receiver. It will revert. This is an excellent question. And yeah, like, let's see, where is that? Yeah, over here. So on the receiver side and on the minting function as well, we're calling the _safe mint function by OpenZeppelin. That means that if the receiver is an externally owned account, that's fine. It will receive the NFT. But if a receiver address is a smart contract, that smart contract needs to implement ERC721 receiver interface. And if it doesn't implement it, this transaction will actually revert. So yes, this implementation assumes that in a cross-chain environment, everything applies from like the actual one chain stuff you are all used to. How do you maintain the ID across chains, or it will be a part of the data sent across? It will be a part of data we send. So over here, you send, you basically say, I want to transfer this token ID. Like this is basically the same as transfer from function signature, just we added the snake chain selector and prefees in as a function arguments. So yeah, if you're not the owner of token ID, this part will fail. So you cannot transfer a token you don't own. And on the other side, because it's part of the data field, you can see here token ID is encoded. Once we decode it, the other side can just remint that NFT with the same token ID. Cool. Okay. If you have any more questions, feel free to drop them in the chat. If not, we can start with the exercise. So I'm going to quickly recreate this smart contract just in Remix. You saw the gist of the most important stuff. I'm just going to show you in a code where all that stuff are actually. I'm going to use Remix for this. You may want to see me how to use it if you haven't used CCIP before, because after this you'll have like your own time to work on the exercise by yourself. So yeah, you can use also Hardhat Foundry besides Remix. I'm going to use Remix, so that means that I'm just going to click on this URL to create a new workspace. Alternatively, you can just git clone CCP starter kits in Hardhat and Foundry. Okay, more questions. I'm going to go that in a minute. I see your question. How does CCP handle such cases? I'm not sure which cases you're talking about. So if you can just write that down, I'll help you. Okay, cool. One more thing. That's what we used yesterday. Like we're using this npm package. This is all the contracts for CCP is. So if you're not using starter kits, or you are not using your repos from yesterday, if you're creating a new repo from scratch in Hardhat or Foundry, make sure to install this package and also OpenZeppelin contracts, because we need OpenZeppelin for our NFT stuff. I'm going to, because I'm using Remix, I'm going to just copy this empty contract and I'm just going to compile it to make sure that everything's working properly. So I'm going to, can you see this? Let me zoom it a bit. Okay, cool. So I'm creating empty.sol, pasting this, saving using Command S or compile empty, and we can see that it's compiled because I can see in artifacts that everything's compiled, and that like in Remix, it will just automatically get your contracts from dedicated npm packages using this syntax. So that's cool. That's what I wanted to just do. Okay, again, if you need tokens, you can go to our faucets. So this is the official faucet, faucet.chain.link. Arbitrum Sepolia will need Arbitrum Sepolia ETH and a link because it is in code, hard-coded to issue the first mint of this contract on Arbitrum Sepolia. Like this is our starting chain, let's say. This is the whole contract. I talked you through the most important stuff. I'm just gonna now copy it to the Remix. I have it over here, but I'm gonna just do like this, okay, and compile it. Before I go to the code again, I want to set up something. So this is important as well. this is about EVM versions. So after the recent development on Ethereum mainnet, like Shanghai, Cancun upgrades, there were added a lot of new stuff like push zero opcode, mcopy opcode, all that stuff that are not supported on other blockchains like Arbitrum Sepolia. So the thing is that you kind of need to have the exact same state if you want to deploy this smart contract. Because again, for burn and mint to work, we need to deploy this smart contract once to each of these supported blockchains, and then using enable chain, connect them basically. So the thing is that if I go back to Remix, I can see that if I go here to Solidity compiler, I can see that the compiler version is 0.8.24. That's fine. But if I click to advanced configurations over here, I can see that EVM version is set to default, and default is actually Cancun. So Cancun has push zero opcode, Cancun has mcopy opcode, etc. It's on Ethereum Sepolia, but it's not on Arbitrum Sepolia, and it's not on Polygon Mumbai, and it's not on Avalanche Fuji. That means that I will be able to deploy this smart contract to Ethereum Sepolia, but I won't be able to deploy it to Arbitrum Sepolia, and that's not what we want. So what you need to do is to downgrade this to Paris. EVM version Paris is the EVM version used by main CCIP repo, and it's currently the EVM version that is the same or support all the same features across all of these EVM blockchains that we support as CCIP. So just click to Paris here and recompile this smart contract again using Control or Command S, or clicking to the compile xnft.sl blue button. If you're using Hardhat, Foundry, or Salts, if you click here, this is a Stack Overflow answer by myself, shameless plug, but basically you can have details about how to perform the same thing in Foundry, Hardhat, or Salts, or of course, if you git cloned our server kits, then you don't need to worry about it. This is already set up. Cool. Okay, let's wait for questions a bit, and then I'll go back. Okay, cool. Next step is to, I showed this, to compile it, to set EVM version. You have like a written guide how to do all that stuff. And because we're going to use Arbitrum Sepolia, if you don't have Arbitrum Sepolia in your wallet, go to Chainlist, just click on this URL. It'll just include Arbitrum Sepolia, connect wallet, and that's it. Or if you want to add it manually, you know how to do that in MetaMask, hopefully. So yeah, you can do that as well. But yeah, cool. Let's now answer questions before we start. So how CCP handle reverts? How are they propagated? So actually, that's up to you or up to us developers to handle all of this, because this is now we are building on top of CCIP. We're just using CCIP as a message transferring protocol, but our NFT collection needs to handle all the edge cases. And I'm going to show you in a minute all the errors that we have in this smart contract. But yeah, you'll need to use Chainlink local to test this correctly. And yeah, I'm going to show you how to do that in 30 minutes. We'll see. Another question is, can I deploy the same NFT smart contract to any L2 without modification, and would I be able to meet there? But is a transfer token ID that makes the NFT unique in other L2? This is an excellent question. Kind of summarize everything that I was talking about. So yes, you can deploy this smart contract to any other L2 as long as you set the EVM version to Paris, just to make sure. This smart contract has like hard-coded stuff. Let me show that to you actually. So it has this constant hard-coded Arbitrum Sepolia chain ID. That means that issuing or initial minting is on the Arbitrum Sepolia chain ID, but you can modify this and just make it different. And then, yes, you can just transfer it across any blockchain. The only thing that makes its NFT unique is the ID on other L2. And the thing is that you cannot have the same token ID or same NFT appears twice because of the way how this smart contract is implemented. So yeah, it's kind of like a unique thing flowing around different blockchain. Will the link to the Stack Overflow page be posted somewhere? Yes, it's in the Git book. Everything's in the Git book over here. Just click here and that's it. Like if you want to study by yourself, just read carefully the Git book and you will be able to answer all the questions from the homework and to do all the assignments. Trust me, like this is the way to learn. Just patient, and yeah, you'll be soon a master of CCIP. Can I deploy this on my GitHub? Yes, sure. Well, great. Share the URL with us. Please show the chain list link to add arbitrary volume. Yeah, sure. So just over here, chain list. If you go to prepare for deployment, select remix tab over here, click here, and you will see this page, connect wallet. That's it. Cool. You're welcome. Okay, cool. Cool, guys. Let's actually do this. So I'm going to do it by myself. Then you will need to do this as part of the exercise. Once you're done, post your CCP messages or like URLs to your CCP block Explorer pages so we can congratulate you on stage. So yeah, let's do it. So first of all, I'll need to deploy this smart contract to Ethereum Sepolia. So I'm going to deploy it to Ethereum Sepolia. This is huge, but okay, cool. So how to do that in Remix? First of all, I need to switch from Remix VM to injected provider and enter my password. Cool. I can see that I'm currently on Ethereum Sepolia. So Sepolia ETH chain ID is 111551111. So I want to, again, deploy this to Ethereum Sepolia. Let's do that. So how to do that? Again, Paris compiled. I'm all set. I have funds, ETH Sepolia, and all of that stuff. Cool. So I already have like one instance, but we're gonna just repeat the process. So I need to provide, if you go to a constructor, by the way, yeah, I forgot to answer that, about the errors, error handling. We have all of these errors to handle that. If router is invalid, if we can only mint arbitrary Sepolia, if we don't have enough balance for cover for CCIP fees, if we have errors with withdrawing tokens from this smart contract or native coin, if sender or chain are not enabled, or if operation is not allowed on current chain. So this is how we handle all the errors by ourselves. If we go to the constructor, we can see here that I need to provide the CCP router address, link token address, and the chain selector of the chain where I am. So this is Ethereum Sepolia. So addresses of router, link, and chain selector on the Ethereum Sepolia. So how to find those? Well, you have those in a Gitbook, right? You can copy paste, but you should always go to docs.chain.link, go to CCIP page, go to supported networks, testnet, and then here you can find all supported test networks. We are on Ethereum Sepolia, so links on Ethereum Sepolia. This is the router address. This is the chain selector. This is the link address. So always copy from here. We can see 0B, 0B. It's the same thing basically. So router address, copy router address, CCP router address over here. Then link address, link address, link address, and the current chain selector. Chain selector. Oh, no, not here. Chain selector. I'm gonna deploy this. My MetaMask pop up. I don't know if you can see that, but I'm hitting confirm. And I'm waiting for transaction to get included in the next block. Okay, here it is. Now, this is my fresh new cross NFT smart contract on Ethereum Sepolia. However, I will pin this. So stop here. If you're in Remix, do this. When you deploy smart contract, always pin it. So hit pin contract here. That means once I switch between chains in Remix, I will have this contract available again. So I will not need to redeploy it or whatever. So pin contract. That's it. So once I switch to a different chain and go back to Ethereum Sepolia, I should be able to see my NFT smart contract over here. So pinned, always pin smart contract. Okay, cool. Let's step number 2 is to deploy this smart contract to Arbitrum Sepolia. So the same thing. So how to do that? I'm just gonna open my MetaMask. You don't see this, but I'm gonna just switch to Arbitrum Sepolia. And with switch, I can see that now I'm on 421614. This is the chain ID or arbitrum Sepolia, and I can see now that my pin contract is not there anymore. This is the another NFT from testing. But once I go back to Sepolia, I will be able to see it. So yeah, this is how it works. So repeat the process just with different addresses. Like we need address of router and link tokens on arbitrum Sepolia and the chain selector of arbitrum Sepolia. So again, now go to lanes on arbitrum Sepolia right over here and router address. This one, copy, paste, link. This one, copy, paste, and chain selector. This one, copy, paste, hit transact, sign MetaMask pop-up, hit confirm, and wait for a contract to be deployed. It's confirmed, we deploy it. Once again, hit pin. We must pin our smart contract. That's it. Cool. Now, let's see. On Ethereum Sepolia, we need to call the enable chain function. And enable chain, let's see the function. So this is the main function, right? How you can mint it, like opens up and stuff. Enable chain, we need to provide a chain selector and cross-chain NFT address. So this is how we can enable the chain that on other side that we want to connect with other instances of our smart contract. So because we're doing this on Ethereum Sepolia, we want to provide the chain selector of arbitrum Sepolia and the address of the smart contract NFT we deployed previously to arbitrum Sepolia. So what I'm going to do is I'm going to copy this address because I'm going to need it, and then switch to Ethereum Sepolia again. So I'm on Sepolia 1115511, and I can see my pin instance over here. We're calling the enable chain. So cross-chain NFT address. This is my smart contract on arbitrum Sepolia. Chain selector is this one, and CCP extra arguments is this huge bytes thing. What is this? Well, let's talk about extra bytes. So we're setting extra bytes because we want them to be mutable. But how we can calculate it? We have this helper smart contract, which is really simple. And essentially, this helper smart contract just accepts the gas limit. And based on gas limit, provides a bytes value. So it can be, we set to 200,000. And that's why we got this value. But you can set it to whatever value. And you can see that it'll look a bit different, but it'll be your CCP arguments field. So you can do this even on Remix VM, like totally locally, because you just need this bytes value. That's it. I calculated for you in the interest of time, and I'm just going to proceed with this. So I'm going to hit transact. And this is Sepolia. I'm hitting confirm. And waiting for a transaction to include, which just happened. Now we go back to arbitrum Sepolia, and from here we're gonna do everything on arbitrum Sepolia. So on arbitrum Sepolia, we need to call the enable chain. So same thing, but in reverse. So what I'm going to do is I'm gonna just copy the address of this smart contract and switch to arbitrum Sepolia for the very last time. Okay, where is my arbitrum Sepolia? It's over here, 421614. And call the enable chain function here. So enable chain X NFT smart contract. Hopefully this is the right one. If I made a mistake with copy pasting, that can be painful, but we'll figure that out. And chain selector for Ethereum Sepolia is this one. So put this one, and extra arguments is going to be exactly the same value. So this. Hit transact and hit confirm. We're waiting for this transaction. That just happened. Cool. Step number 4 is then on arbitrum Sepolia, we want to fund this smart contract with 3 links. So you're just going to get a link from a faucet, and you're just going to open your MetaMask like this and put the address of your smart contract instead of this one and just send 3 links. And that's it, like simple as that. So that's what I'm going to do. Now I'm going to copy address, open my MetaMask. I'm on arbitrum Sepolia, select link, hit send, address. I got a warning, you're about to send token to a contract, which could result in a loss of funds, but I'm gonna hit I understand because I know that I have a withdrawal functions as well. So that's like another best practice. Like always, if your smart contract will receive tokens, just implement withdraw token function, and so you can withdraw any ERC20 token or native coin from it. And I'm gonna just hit next, funded with Chainlink, hit confirm, and wait for this transaction to include in the next block. I'm gonna figure out how to share my MetaMask pop-up with you guys. This is just because of the security privacy reasons. I have something set up, sorry about that. But what I did that you kind of didn't saw is that I sent 3 links to my address. And now I'm gonna just mint one NFT to myself, because minting is, if you go back to mint, anyone can call it, but only on Arbitrum Sepolia. For free, I'm just gonna mint one NFT to myself by clicking the mint button, MetaMask pop-up, I'm hitting confirm. I'm waiting for this transaction to include in the next block, which just happened. We saw green thing here. And I'm just gonna validate that balance of my address should be 1, right? So balance of my address should be, yeah, it is. And the owner of token ID, of token 1 actually, should be no one. Okay, cool, error, but token ID 0, like the first one, should be my address, and here it is, it's my address. So cool, I successfully minted NFT on source chain, on Arbitrum Sepolia, and now finally I'll just cross-chain transfer it to myself, but on Ethereum Sepolia, using the cross-chain transfer from function. And this is the final step, number 7. So cross-chain transfer from is this function, cross-chain transfer from. I need to provide from 2 addresses. Those are both mine. So from my address, I want to send to my other address, but on Ethereum Sepolia, another blockchain. I'm sending token ID 0. I'm sending this to Ethereum Sepolia. So I need to get the chain ID, CCIP chain selector, CCIP chain selector of Ethereum Sepolia. So CCIP knows which lane to take, and pay fees in, that's enum. 0 is for native, 1 is for link. So you can see that this is basically an enum, which is uint 8 under the hood. So enum is 0 is native, 1 is link. Because I funded my smart contract with links, I'm gonna just say set 1, and you can see set 1, which is link, and this is cheaper for me in general, and I'm gonna hit transact. Another MetaMask pop-up. This is great, right? I'm gonna hit confirm. I'm gonna grab the transaction hash of this transaction. So I'm gonna just grab this transaction hash. It's right over here. And I'm gonna go to ccip.chain.link. This is the Chainlink CCP Explorer. I'm gonna paste it here, hit enter, and I can now watch the transfer of my cross-chain NFT in real time. And that kind of concludes our first exercise. Now you have time to do the same. And we are basically gonna ask you, once you're done, to send this URL to chat as a proof that you successfully completed the first exercise. Now I'm gonna play some lo-fi in the background. I'm gonna answer some questions, if any. Feel free to drop them in the chat. I see that Zubin already answered couple of them, so thanks for that. And yeah, we're gonna see you again in 20 to 30 minutes, depends how it goes. Sounds good? Okay, cool. Let's play some lo-fi. Which one? Let's do this one. Is it too loud or whatever? Just tell me if it's too loud, too low. We can adjust that as well. Or if you don't like the track, we can do that as well. Okay, I'm gonna answer a couple of questions. So if you have any question, I'm just gonna lower this down. So if you have any questions, feel free to drop in the chat that hasn't been answered yet. Common ones are that I saw so far. So if you are switching between windows in Remix, when you deploy your contract, make sure it's pinned. So pin your smart contract. Pin, because in Remix, you kind of want to do that, right? Second one is Solidity compiler. Set the compiler version to Paris instead of the Cancun, which is default, because it won't work on L2s, just on Ethereum Sepolia. If you're using Hardhat or Foundry, I also just git cloning starter kits. But if you want to set up from scratch, that's totally fine. Just drop the common questions if you have in a chat, and we should be able to help. And yeah, finally, after this exercise, you won't even care anymore about all this hustle with setting up, Remix, pinning, unpinning, tokens, faucets, all that stuff, because the next section is actually how we can simulate all of this stuff locally in a local environment much faster. And that's like what development should look like in the first place. Okay, cool. So if you have any questions that has not been answered yet, like that one about the link to the Git book you're looking for, feel free to drop in chat, and either myself, Zubin, or Richard will help you. Cool. This is an excellent question. So yeah, the good thing about CCIP Explorer is, where is it? Oh, it's right here. That you have this elapsed and expected total time, and this is pretty accurate. So as I said, because we're sending from Arbitrum Sepolia to Ethereum Sepolia, we need to wait for finality in Arbitrum Sepolia. Yesterday, we sent everything from Avalanche Fuji, and Avalanche Fuji has a really fast finality time, so it takes like two to 3 minutes to transfer everything. But here, Arbitrum Sepolia, because it needs to get finalized on L2 and then finalized on L1, it's a longer time, longer process. That's why we're waiting for this transfer for 25 minutes. And that's cool, because like other bridges, like, I don't know, try bridge something from L2 to Ethereum, it's like 7 days. So this is like much faster, right? The problem with this is, like, if you're waiting for cross-chain transfer, is during the development phase. Like, you don't want to build directly on testnets, because, like, imagine that you have a bug and now or issue or whatever, and you're waiting for 25 minutes just to find out that you have a bug. You want to develop locally much faster. That's why we develop Chainlink Local, which we will have as a next exercise. However, for testing and production, this is totally fine, because we cannot compromise on security. And that's one of the questions for homework. So yeah, make sure you understand what's going on here. Where is the link for the Git book? Okay, let's drop it one more time. So link is this. Bookmark it. This is the book for all 3 days for homeworks. Oh, twice. Okay, cool. Yeah, all the details are here, and it's literally like a book. You can always refer back to it. It'll always work. It's a cool concept, so you don't need to rewatch videos if you're not that type of learner. I personally are not. Okay, any more questions? Thanks, Vipin. Another good question. So let's lower the music down so I can talk. Another question. So is it the source that determining this finality, not the recipient, or is it a combination of both? Yeah, just source. So you have a first transaction and you kind of don't want that transaction to end up on a fork. It needs to be on a canonical chain, like we're waiting for finality. And then CCIP will deliver the message, and then you'll have another transaction. Now that second transaction, it's up to you now. Like you as a user, do you want to wait for that transaction to get finalized as well before any next action or not, right? So, that's a common thing across all blockchains. It's really something that you guys need to understand. It's not it's like related to CCIP, but kind of it isn't. Like in general, like this is how it's all tied up to double spending problem, which is a core of all blockchains. So make sure to understand finality. And actually, let's show you something. So okay, this is for homework, but doesn't matter. Like one of the answers for homework, you can find it here. So basically, if you go to concepts and to conceptual overview over here, you can find and read about the finality. So what is finality in general on blockchain space and why it's important? In CCIP, we care about finality on source chain only, and then we're going to deliver it to you. But you as a user should think about it. Do you care about the finality on destination chain as well or not? I hope that answers your question. Another question, is that why our lanes are unidirectional? No, actually lanes are bidirectional. So where is that? That should be here. So this is the example of one lane. So lane is a unique path weight between blockchain, CCP support blockchains. So if you're transferring CCP messages from blockchain A to blockchain C, this lane will be used. If you're replying back from C to A, this lane will be used. And this is how it looks like on a high level overview in general. So it's bidirectional lane. Okay, cool. If you have any issues with the example itself, just make sure that you follow the steps correctly, that you copy paste the stuff correctly, that you have enough tokens in a wallet to cover for gas stuff. If network is congested now, if we're all trying to do the exercise, etc. But here you should be able to read carefully about all the steps needed. So just deploy contract twice, call enable chain function twice, fund contract with Chainlink, and finally do a mint and cross transfer from. It's not that hard. Trust me. Like, just take your time. You got this. You got this, definitely. Cool. Let me just scroll up. We're still doing the exercise. So yeah. Let's play some music. Just a reminder, once you're done, drop the URL to the CCIP Explorer in a chat so we can validate that you successfully completed the exercise. Mine is still waiting for formality. By the way, you don't need to refresh. It's automatic. It's really cool. So we can see that source transaction hash is here and the destination transaction hash is to be available after we have a blessed status over here. So yeah, once you're done, just copy this, drop in a chat, and that's it. Okay, cool. Another question. Step number 5. Let's see what's step number 5 actually. Step number 5 is funding. Yeah. So on step number 5, I need to fund the arbitrum contract that I just deployed. Right. So you open MetaMask. This address will be your contract you deployed. Send 3 links or 5 links or whatever to it, and that's it. That's the funding part. Simple as that. Sorry you wasn't able to see my MetaMask pop up for some privacy reasons, I guess. I'll fix that. But yeah, that's it. Just do that and you're good. Okay, guys, how's it going? We're almost on time, so we should move to the next exercise soon. I see a couple of questions in the chat as well being answered by Zubin, so thank you for that. Yeah, this is a good one. Checking the CCP Explorer seems that it may be because it hasn't reached the final status. Waiting for finality, that's it. Like, if you recall, I here had like another status, which was waiting for finality. And after that, we have a green success. So again, just wait for finality, wait for finality. You did it, guys. That's it. Like, if you want, you can drop your URLs of CCP messages in the chat so we can see it. But yeah, that's it. Like, after that, you should be able to see in 20-ish minutes this page, the green success. And yeah, that concludes this exercise. Saying here, just waiting for finality. Nice job, Juan. Yeah, that's it. You guys, you did it. You made it. That's great. So yeah, congrats. Really happy about you. This is a huge progress. So yeah, that's good. Cool. Now, another waiting for finality for Ferdinando Agneloni. I hope I pronounced that correctly. Congrats, man. That was awesome. So yeah, a lot of waiting for finalities. That's cool. That's what we wanted. And yeah, like the thing is that imagine, like, as I said, like testnets are for testing. We some of you have issues with getting tokens, faucets, all that stuff, spikes, all that stuff. But essentially, when you're in a building phase, you want to build everything locally, and that's why I'm gonna remove this banner. We're gonna continue with the next exercise. And the next exercise is exercise number 3, where we're gonna talk about how you can test cross-chain contracts using Chainlink Local, the Chainlink Local simulator. So if you've been following us for a while, I remember like since the official launch of CCIP and ECC last year, and after a couple of initial masterclasses, CCP masterclasses with it, and the fall hackathon as well, there was a lot of feedback from you guys, from developers, that everything's great, like CCP is cool, but like initial building is hard and slow because of waiting for finality, which we're all waiting now on different chains. And the thing is that, like, when you build something, like I remember I was building like initial starter kits and tutorials and all that stuff, direct and testnets. Just to realize that I had like an issue or a bug, and then I need to fix my contract, redeploy it, etc. So it's really like, imagine that you're building a website, but every single change to a button or something like that, you need to redeploy your, let's say, is Vercel still popular? Let's say redeploy to Vercel, and imagine that takes like minutes. Or imagine that you're building like an Android game or whatever, like mobile app, and then with each new change, you push a new build, which is a couple of minutes or tens of minutes need to rebuild just to see the progress. That's, that's not ideal. That's not ideal in the development phase, because, okay, cool, like waiting for finality or waiting for new build or waiting for website to republish is a good time for us developers to grab another cup of coffee, but essentially slows us down a lot. So, like, we want to move fast, to iterate fast, and that's why we have developed, as based on your feedback, Chainlink Local, the CCP Local Simulator. So Chainlink Local is available if you click on this URL or go directly on GitHub on Chainlink-local URL on GitHub. So if you go to, sorry about that, if you go to official smart contract kit GitHub repo, you'll find Chainlink Local pinned as well. But if you go to this URL or just click this link, you will find the official repo of Chainlink Local. If you click over here or down here, you'll find the temporary Chainlink Local documentation. This is a temporary Git book. This is in process of moving to the official Chainlink documentation. So pretty soon you'll say, like, if you go to docs.chainlink, you'll see dedicated section for Chainlink Local. But for now, we have a helper, which is this Git book. And also, if you're more like a visual learner, then in the README, also, if you click here, this is a YouTube playlist with 5 different examples of how you can use Chainlink Local. But essentially, Chainlink Local is just an installable dependency, kind of like OpenZeppelin. Like you install OpenZeppelin to your project, and you can install it to and use in Foundry, Hardhat, and Remix. So for the install Chainlink Local, npm install Chainlink Local on Remix, just simply import it. Now, Chainlink Local supports two different modes, local mode and fork mode. So we're going to stop here. This is an important architectural decision. So local mode is essentially everything is locally on a blank Anvil or Hardhat node or Remix node VM state. So essentially, you're importing CCP local simulator smart contract from the Chainlink Local package. And when you create a new instance of that smart contract, like CCP local simulator equals new CCP local simulator, that command will pre-deploy all necessary CCP contracts, mock versions under the hood to your blank state, Anvil, Hardhat node, or Remix VM. And then you're just going to call the configuration function of it. You'll see that. And similarly to grabbing all the config details from the official docs, you're just going to grab them from the configuration. Another one, second mode, is fork mode. So fork mode basically use the actual smart contracts on actual blockchains. So you create a fork of Arbitrum Sepolia or Ethereum Sepolia or Avalanche Fuji or whatever in this block, that block, that block. And then you just go to the docs, or there are some predefined values in a simulator as well, and use the actual contracts, the actual state from the blockchains you're testing. Same goes with mainnet. It works with mainnet, but you'll see a notice in the docs that for mainnet stuff, you'll need to enter details manually because it's mainnet, just to be sure that all addresses are correct. And yeah, for this exercise today, we're going to use fork mode, which is harder. That's why we're using it now in Foundry. And I'm going to show you how easy that hard part is actually. And for homework, you're going to use local mode in Hardhat. That's it. So after you complete this exercise and your homework, you're going to be a Chainlink Local Master. And a lot of projects that use Chainlink CCIP in production actually find this tool really helpful because it's much faster for the initial state of development. After that, you move to staging area, which is like testnets, and then you can do a proper tests on testnets and then mainnet. But initial development, like to see whether your smart contract logic is correct, whether you don't have any errors, simulator is the tool for that. Okay, cool. This is just details about local and fork mode, nothing fancy. And now let's do the exercise. Like let's write a unit test for our cross-chain NFT smart contract. The full example is available in this URL. And if you git clone it, you'll see what's going on. So CCP cross-chain NFT, this is the one that we are going to use today. I suggest you to just git clone it and you will find the actual test. Look, this is the test we're going to create, but I suggest you like do either delete that file or create a new one and just start from scratch for the educational purposes. Or if you really want to set up your project from scratch, then you can do it like this. So you can create a new Foundry project using the forge init command, and then you can install all necessary dependencies: Chainlink contracts, Chainlink contracts CCIP, OpenZeppelin contracts, and finally Chainlink Local. If you don't want to commit each change after each installment, you can just append no commit flag to the end of all of these commands. This is pretty standard Foundry stuff. If you're not fluent with Foundry, no worries. This is supported also in Hardhat and Remix. But for this exercise, you can just git clone this repo and just use it because this repo is actually pre-set up with all of this stuff. Of course, if you are not using Foundry, but you're using, let's say, Hardhat, like then there is a Chainlink Local package. Like then you're just using npm package, using npm install. So npm, oh, here it is, Chainlink Local. So you can see the URL is missing, but this is the npm package for Chainlink Local. Here, you just install it as is. This is this is important for your homework, for example, because you will need to go to this page to install Chainlink locally. Just FYI. Cool. So if you want to git clone this repo, feel free to do so. I have it already in my my Visual Studio Code. Once you're ready, we are gonna switch to Visual Studio Code, and we are going to perform the actual exercise. If you want to do manual setup, this is how you do the remappings. This is the source version I'm setting to 8.24, like we did, and essentially this is how you can set up the whole repo. The second thing is, because we are going to use fork mode, that means that we are literally going to use contracts on testnets, like literal CCIP contracts on Arbitrum Sepolia and Ethereum Sepolia. For that, you'll see that you'll see that in the repo that there is an env example file over here with a bunch of stuff, but we'll need Ethereum Sepolia and Arbitrum Sepolia RPC URLs, just these two. So just create env file with these two values, and instead of these double quotes, you will need to provide the JSON RPC URLs of the archive nodes, of the RPC nodes with archival mode turned on. And for that, you can use services like Infura or Alchemy, or if you have your local nodes, that's fine. So I'm using Alchemy. So if you go to Alchemy, like dashboard, I have Sepolia key, I have Arbitrum Sepolia key. I'm just grab those values, copy paste. I won't show it to you, so you don't reach out my my requests. But essentially, you're gonna just put those here in .env file, and once you git clone the repo, and then you'll be ready to run the test. This is for fork mode. For the local mode, you won't need to do anything of this stuff. Local mode for homework, it's much easier. It's just one local chain. And yeah, if in Foundry, if you're setting everything by yourself, just add these 3 lines to the Foundry toml config file at the bottom of it, so Foundry can recognize these values in it. So yeah, that'll be it. Now we can actually write our first test using Chainlink Local. I'm gonna stop sharing this slide, and I'm gonna share my Visual Studio Code. Let's see if my invite is open. It's not. Okay, cool. Just give me 30 seconds, please, to collapse all that stuff, and then we can start, right? Okay, cool. So present. We are going to present Visual Studio Code now. That'll be this thing. And you should be able to see my Visual Studio Code. I'm going to clear all of that stuff. I'm going to zoom this as much as possible. I hope this is all right. If not, just tell me, guys. We can adjust. And here, if you git clone the repo, you'll see that this is exactly the same smart contract we used in the previous exercise. So no further coding of smart contract needed. We're just going to use exactly the same cross-chain NFT smart contract from the previous exercise. You can see all the errors we talked about are here. Same goes for IPFS images and all of that stuff. So this is the contract we are going to use. The difference is that we are going to create a new test file. So to do that, I'm going to go to the test folder over here and create another xnft.t.sol file, which is a test file. So each file that has this .t thing in Foundry is actually, that's a convention for a test file. And to make stuff easier, I'm just gonna copy all of this stuff from other tests. Okay, cool. I'm gonna collapse all that stuff. So test and console just from Foundry stuff. And this is the contract we're using. We have this encode extra arguments from the previous exercise, if you recall. So if I go here, this is the exactly the same one from From the Git book, it just does nothing but encodes extra arguments based on the provided gas limit. So we can play with this. We're going to need it in our test as we needed in the previous exercise. So that's what we imported as well. And finally, we imported CCIP local simulator fork from Chainlink local. This is for fork mode. For your homework, you're going to import CCIP local simulator, just CCIP local simulator from Chainlink local, etc. Like this. That's fine. That's it. Okay, cool. Okay. Question: can't find OpenZeppelin contract security when compiling. Make sure to check the address. The version of OpenZeppelin, they recently bumped it to 5 point something. So if it's not in security, maybe you install the older version that can be in utils. So just make sure to find that path correctly. Okay, cool. So how to use CCIP local simulator? Well, it's really simple. So as I said, we create a new instance of CCIP local simulator fork like this. So that'll be, we can do like public things like public CCIP local simulator fork. This is a variable. And the thing is that we're going to create a new forks. So we'll need fork ID for Ethereum Sepolia. So it's Sepolia fork ID and arb Sepolia fork ID. Arb Sepolia fork ID. And then we're also going to need some network details. So that comes from register contract network details. And this is only for fork mode. For local mode, you don't need this. It's Sepolia network details. And we're going to do the same for arbitrary Sepolia. Okay, cool. Now we're going to create a setup function setup. There should be like capital U, I think. Public, we'll see. And then in a setup function, if you go to official Foundry documentation, like Foundry book, you will see that this is how they create a new fork. So basically, they do string memory, and then Ethereum Sepolia RPC URL, which is VM env string of this thing. I hope there is no typo. And we're going to do the same thing for Arbitrum. So there'll be Arbitrum and there'll be Arbitrum here. Sepolia RPC URL. And then we're going to assign this fork. So it's Sepolia fork ID is equal to VM create and select create. So this thing is really dumb, but create select fork for Ethereum Sepolia RPC URL. That means that we created a new fork and also selected this one to be our fork, and Arbitrum Sepolia fork will be the same thing. So how we can do this? If you remember, like fork ID, chain ID is different to chain selector in CCIP, but chain ID for Ethereum Sepolia was 111.55111 when we swap networks in Remix. So what I can do now is I can try maybe to console log to make sure that I'm on a select fork. So to do that, I can do console log block chain ID. So this should be 13337 for localhost, but if I set up all this correctly, it should be 111.55111. So this is just a sanity check, and I can just do function test smoke, and then public, and then actually here I can console log it like this. And if I run forge test www, I should be able to see the chain ID, which is 111.555.55111. And it's not, because I created another fork and selected using Arbitrum, so this should be create fork. And now, like we remember that 4216414 is Arbitrum. So this is good, actually. It works, but I'm gonna just repeat the process one more time. So you can know that how to set up this properly. This is Sepolia, so that's cool. Like this is how you can switch between different forks in a single Foundry test. And yeah, that's pretty much it. I'm going just to clear all of this stuff up, and let's continue with our stuff. We also have CCP local simulator. So CCP local simulator fork equals new CCP local simulator fork. This is how we set up the simulator. And finally, the one thing that we need to do is to make this persistent, right? So to do that, persistent, that means that we will have this smart contract available on all of these multiple forks. I hope I don't have like this typo, because if we don't have that, that's kind of like similar to like pin feature in Remix. Let's say like we need to be sure that we have it on both sides. So I have like typo here. So instead of like looking for this, we can just do, oh, it needs to be address of CCP fork. Okay, sorry about that. So this should be address, right? Okay, let's please this. Okay, this is cool, right? We set up our simulator properly. So like what, 20 lines of code to set up simulator, and now we can write our tests. So if you never write tests with Foundry, I'll show you. It's really easy. It's just Solidity. It's really handful. So essentially, we will have two personas. So we can have Alice and we can have Bob, and also we will need to have two cross-chain NFT smart contracts, at least, like on Arbitrum Sepolia and on Ethereum Sepolia. So there'll be XNFT. Yeah, we can do it like at Sepolia and then Arbitrum Sepolia. So that's pretty much it. And now we want to, first of all, assign addresses to Alice and Bob, so that make a DDR cheat code is used from Foundry for that. That means that we now have some valid addresses for Alice and Bob. And we now need to just deploy our smart contracts from our previous exercise. So basically, I'm just going to put comments the same way we had in a Gitbook. So that'll be step number 1, deploy cross NFT to Ethereum Sepolia. Now it's smart because it just reads the other file. Never mind. So how to do that? First of all, we'll always assert that active fork is the one that we want to be. This is just a security measurement for Foundry. It's nothing like nothing that we cannot live without. Like we can live this if you want, but this is again a good security best practice. So we're on Ethereum Sepolia, and also I'm going to validate that details like Ethereum Sepolia network details are the one are set up in get that network details function. If not, there is another set network details which you can set, and as I said, like for mainnets we don't have anything set, but for testnets we do, and that's for security reasons. So this means that if I console log, I don't know, like chain selector, it shouldn't be 0, should be something different. Like let's try to do that. So console log it's Sepolia network details chain selector and see what's going to happen. So forge test www again, and yeah, this is the chain selector. And if you go to official Chainlink docs, you'll find that this is the chain selector for Ethereum Sepolia. So what I want to do is to assert that, yeah, this chain selector is actually this value. So I'm gonna just copy it from here. It's the same thing. So yeah, that's pretty much it. Now I'm just gonna deploy new cross-chain NFT. And if you remember from the previous exercise, we need to provide the router address, the link address, and the chain selector of the blockchain we are in. So all from the Ethereum Sepolia. And we can just grab them from network details because that's already pre-populated. And I'm gonna just hit tab. Now, let's do the same thing, but for Arbitrum Sepolia. So same thing. Step 2 is to deploy this to Arbitrum Sepolia. And this is going to be much faster. So we're going to switch now to Arbitrum Sepolia fork. We're going to assert that active fork is Arbitrum Sepolia. We're going to quickly assign this Arbitrum Sepolia network details to another blockchain ID now because we're on Arbitrum Sepolia. Yeah, because we're now on that fork. And then we're going to assert that, again, sanity check, this is set to the correct value. We can always double check these values from the main Chainlink official docs, and we're just gonna deploy new NFT like this. And yeah, that's pretty much it. Now from step 3, we're gonna actually put everything in a test, because this is just a setup that we had. So if we go back to our official Gitbook, we can see that step 3 is to, I can just grab that, yeah, the on Ethereum Sepolia call enable chain function. Step 4 is on Arbitrum Sepolia to call enable chain function. Step 5 is to on Arbitrum Sepolia to fund on Arbitrum Sepolia fund xnft.sol with 3 link. Step 6 is to mint a new NFT with token ID is 0, but never mind. So mint a new NFT to Alice. And step 7 is transfer NFT from Alice to Bob. Actually, XNFT. And that's it. And now I'm going to show you how you can do that much faster in the Foundry local environment instead of like waiting for 25 minutes. Okay, cool. So first of all, we are on Ethereum Sepolia. So once again, VM select fork on Ethereum Sepolia fork ID. And we're going to assert that active fork is Ethereum Sepolia. We'll need to call the enable chain function. And if you remember, for enable chain, we need to provide the address of a chain selector, the address of the XNFT smart contract on that chain, and the extra arguments value. So how to do that? First of all, let's utilize our extra arguments. So encode extra arguments is a new helper utility smart contract. And this thing, actually, I can put it as a storage variable right about here, let's say. So there'll be bytes public encode extra arguments. That's fine, right? We can just put it somewhere. Actually, no bytes, but let's do a contract. So encode extra arguments because it's a contract, right? Yeah, let's do it like this. And what we want to do is essentially to set up a gas limit. So let's do Union 256 gas limit. In exercise, it was 2100, but we can tweak it to see how it works. And then bytes memory extra args that we want to actually send and be mutable is encode gas limit. And what you can do is console log bytes, I think, extra arguments. Let's see if that's going to work. Foundry. Hopefully it is. Okay, cool. So if I do forge test again, www, I should be able to see that value we had from Gitbook, and that's how I got it essentially. Here it is. Let's put it here. And now, for the sake of exercise, let's change it to 500,000, and let's see what's going to happen now. Okay, cool. Let's copy this. And we can see that it's pretty much the same, but like at the end is different. That's why, because it's a different value essentially. So, you know, it's nothing like magic or whatever. It's not like copy paste or whatever. It's literally from this smart contract. I'm gonna put back to 200K. I don't need this. I just want to do another sanity check, which is to assert equal that extra arguments. Oh, yeah, that extra arguments is equal to hex and then this value, right? This is just another sanity check. You totally don't need to do that in production, but yeah. Sorry, in your test. For production is fine. But yeah, this should be it. And I'm just going to run this test once again, just as a sanity check, and we can just continue with our stuff. So our stuff is basically to call the, what's the name of the contract? It's Sepolia cross-chain NFT. So to call the enable chain on Sepolia cross-chain NFT, and we need to provide the Arbitrum Sepolia chain selector, the address of this cross-chain NFT, so arb, Sepolia, cross-chain NFT, and extra arguments. I think this is correct. And yeah, that's it. Now we need to do the same thing on other side. So we're gonna go to Sepolia so that we are on Sepolia. Then we're gonna call the arb, Sepolia, cross-chain NFT, enable chain, eat Sepolia, extra arguments, and that's pretty much it. Now, step number 5 is, again, we are on Arbitrum Sepolia. Just assert that we are on Arbitrum Sepolia. We need to fund our smart contract with links. And in Remix, we did that just by go to MetaMask and sending 3 links to our smart contract. But the thing is that we kind of need to go to the faucet first to get those 3 links. Here we have a function by the simulator. So CCIP local simulator fork dot. We have a function called request link from faucet. So I'm just going to use request link from faucet, and I'm going to just provide the receiver and the amount of link I want, and it can be whatever. The thing is that this is actually using the actual smart contract. So if the faucet is empty in that block, that's kind of gonna screw this test because it's all real data. In a local environment, you don't have that issue. It's literally unlimited amount of link tokens. So just be aware of that, but it should work in a general case. So I'm sending 3 link to Arbitrum Sepolia cross-chain NFT smart contract. This is how I did funding. Now let's do the minting. So how we'll do the mint? First of all, we're gonna again be sure that we are on Arbitrum Sepolia. This is just a sanity check. We are, and then in Foundry there is something called prank cheat code. So prank cheat code means that this persona is now calling the function, and I want Alice to call the function. Thank you very much. I was unmuted. Sorry about that. So what I said, I'm going to rewind for 30 seconds. Hopefully it was just that. I was said that I'm going to just do some sanity checks. I expect token ID to be 0. And okay, you can not hear me well yet. Sorry about that. Let's. How about now? Is it better? Can you hear me? How about now? I'm going to repeat everything. Looks like my headphones died. If you can hear me, just drop that in the chat. Fantastic. Okay, apologies for that. We're going to just rewind to prank. Sorry about that. It's just my battery. My headphones died. Okay, cool. So in Foundry, there is a cheat code called prank. So you can call it by start prank and stop prank. Means that when you put a persona as an argument to that prank, that means that that persona is now acting as a message sender. So now Alice is calling the next function, kind of like you switch to Alice wallet, even though you can't. And Alice will just call the mint function in Arbitrum Sepolia cross-chain NFT, mint. We did a couple of sanity checks here just to make sure expected token ID is 0. We are just asserting that owner of this token ID is Alice and that balance of Alice is 1. And what I did then is I just run the forge test once again to make sure that everything's all right. That's pretty much it. Finally, what we came for is to test that we can transfer cross-chain NFT from Alice to Bob, calling the cross-chain NFT transfer from. So I'm not gonna stop pranking because I still want to call this from Alice. So what I'm going to do is I'm just gonna call Arbitrum Sepolia cross-chain NFT. So arb Sepolia
cross-chain NFT, and then the name of the function is cross-chain transfer from, and we need to provide the address of from, that'll be Alice, the address of to, that'll be Bob, token ID we're sending, so that'll be that token ID is 0, the chain selector of Ethereum Sepolia, because we're sending to Ethereum Sepolia, and we're gonna pay for fees in Link. So this should be accurate, we'll see. Finally, I'm just gonna stop prank, VM stop prank. And I'm going to run my test once again. Yeah, okay, cool. It's green, it's passing, that's cool. Finally, we need to make sure that on Ethereum Sepolia, we actually received the token. On Ethereum Sepolia, check that Bob is owner of cross-chain NFT. So to do that, I'll just do console log it Sepolia cross-chain NFT, owner of token ID of 0, and that should be Bob's address, right? And I'm going to run this test. First of all, I have an error because I need to switch. Okay, I expect an error, but not this one. So first of all, let's switch to Ethereum Sepolia. So fork ID, and let's run once again. So we saw in the previous error that there is no token ID 0. There is no owner of token ID 0 on arbitrary Sepolia because we burned it, right? But we kind of expect for Bob to have it on the other side. But the thing is that it won't. It'll revert with non-existent token. And why is that? Well, because here, when we do a cross-chain transfer from, it's just a first transaction on you saw on CCIP Explorer. This is just the first transaction that emit an event that we want to cross-chain transfer this token. And from that point, CCIP will pick up that event and deliver the message, and you can see the status live on CCIP Explorer, all that stuff, and you will see it on the other side. Here, in a local environment, the one thing that we made assumption for when building this tool is that CCIP will just work on testnets and mainnets. So there is no any offchain component or any Docker images or anything that you need to spin up here in order to make Chainlink Local to work. And that's why Chainlink Local is so fast, because it's all smart contracts. However, if you want to deliver your cross-chain message in a fork mode, for local mode this is not necessary, what you need to do is to, first of all, delete this. And here you can do CCIP local simulator fork dot switch chain and route message. That's it. So this is how you simulate the off-chain stuff that CCIP is doing for you. You just switch to different chain and route the message. So how to do that? You just provide to which chain you want to switch, and that's Ethereum Sepolia fork ID. You're switching to Ethereum Sepolia fork ID, and that's it. CCP Local Simulator is smart enough to find your cross-chain message across all of these event logs and deliver it for you. And that's pretty much it. Now, if I run my test once again, I should see that the owner of token ID on Ethereum side is actually Bob's address, because this is the part where we switch chain and route messages. And this is it. This should be Bob's address, right? instead of console logging, what we can do is we can do a couple of sanity checks. So first of all, we want to assert equal that active fork is Ethereum Sepolia. Then we want to assert that owner of token ID is actually address of Bob, right? And we can also assert that balance of Bob is 1. And if I run my test for a final time, that kind of concludes in a TDD manner that our contract is, or our test is correctly written. And yeah, that's pretty much it. It's passed, and now it's your time to git clone this repo and try by yourself. So I'm gonna just share something more to show you for homework. I think there's gonna be a lot of questions about homework before we have a guest lecture. So let's do one more time. So exercise number 3 is where we left. So again, git clone this repo or set up it by yourself. Get this URLs, and basically you can just copy relevant parts of code. Here it's split up in multiple stuff, so you can just read carefully again if you want. This is all the stuff that I did in a video as well, all the details, all of the steps. Or if you want just to get the full final code, you can just copy it from here. This is the final code, and just see that everything's work. And that's pretty much it. So after that, we will talk about homework, about some debugging tips and tricks, and then we will have a guest lecture. So if you have any questions, drop them in the chat. This should be much faster. So let's play some lo-fi. And yeah, this one is good. If you have any questions at all, yeah, just drop them in the chat. We should be good. Again, apologies with the issue.
Okay, guys, I see that you have a couple of questions, so I'm going to try to answer them really quickly. So for the previous exercise, what does the ready for manual execution status mean? That means that you have an error on your side, on the receiver side. And that means that if you can fix the error by calling some other function or whatever, you can trigger the manual execution by connecting your wallet. We're gonna get that in a minute. This is a question about Chainlink local. Is it possible to create lanes? So the answer is that in local mode, everything is like one local environment, and technically, like, you can do whatever you want. In a fork mode, we use already deployed CCP contracts. So if contract is not deployed, then you cannot use that contract. But going back to the manual execution, so over here there is a page for debugging tips and tricks, and essentially this is how you can debug something if you're building on testnet directly, like without Chainlink local. So essentially, if you can decode error message, for example, here, there is a huge possibility that you haven't called the enable chain function, or you copy the wrong address or whatever. So if you haven't called the enable chain function, that means that chain not enable function error can be thrown. And if you go to your CCP Explorer page, you can see something like this, and then here the red button to manually execute it. So if you call the enable chain, you can manually execute this, for example. Or there is this CCP revert reason script. So if you're familiar with Go, you can just use it, provide contract address, all that stuff. Transaction cache, sorry, not contract address, chain IDs, and it will work. Like, it's pretty cool. You can, so this is how it looks like for manual execution. Maybe gas limit is not set correctly, so you can always override gas limit and try again. And finally, well, Tenderly is your friend. So you can just copy paste the transaction hash from failed transaction on the other side, paste it to Tenderly, and see the actual error and what went wrong. So all that stuff is pretty cool. But obviously, the first step should be to use Chainlink local, because here in terminal, you can always see the error message much better. Finally, if you're done with this exercise, there is day 2 homework, where you're going to use Chainlink local to write tests for this repo, cross-chain NFT, cross-chain name service, which is a repo in Hardhat, and we use fork mode with Foundry. Now you're going to use local mode with Hardhat. You can use documentation for this, and essentially you need to create a tiny test. It's literally like this. So you need to create an instance of CCP local simulator, call the configuration to create instances of these 3 contracts, call the register contract, call the register function, and then on the lookup assert that alice.ccns is the address of Alice, and that's a successful test. Then you will put that in a public GitHub repo, either a fork or this one, or publish a new one. And using this form, you're just gonna provide the address of the GitHub URL. Again, this is whatever .com. Here, you're just gonna, again, this is the steps. And again, you're just gonna provide the URL for public. Please be public GitHub repo so we can see your assignment. And that's homework for day 2, where you're going to practice a little bit more of Chainlink local, and you'll essentially be a Chainlink local master. And now we have a guest lecturer. So coming from Celo team, our good friend Sophia, she's the developer relations engineering lead at Celo. You can follow her on Twitter here. Also, details about Celo, will join us on stage to talk about what wonderful cross-chain stuff you can do with Celo. So let's just remove this banner, let's stop sharing my screen, and let's invite Sophia to stage. Hey, Sophia, can you hear us?
Yes, I can hear you great. Can you hear me okay?
Yeah, you sound perfect. The floor is yours.
Awesome. Well, super excited to be here with you all today. I'm going to go ahead and share my screen. There we go. Oh, sorry, let me get started on here. Well, anyway, I'm Sophia. I'm the DevRel engineering lead at Celo, and today I'll be specifically sharing about how you can mint Ethereum NFTs paying with Celo gas fees. I know today you've done a lot about talking about CCIP and what that means in general. What I'm really excited to share is what this actually means for application developers. So why I'm excited about CCIP is this completely opens up what is possible, what you're able to build, and can completely transform your applications. So right now I'll be giving just a small snippet of what this actually means for, say, doing an NFT minter, a cross-chain NFT minter, which seems like it's really simple, yet I haven't really seen this being implemented at wide scale. So I'm excited to share this today. A little bit of what I'll be talking to. I'll be doing a bit of introduction to Celo for anyone who's new to our ecosystem. And I'll be talking about what integrating CCIP actually means for your dApps. And finally, we'll be spending the bulk of our time showing an example of this app, what it is, and you'll have all of the source code to follow along and either fork it, add new features, and make it into whatever you're interested in doing. So a little bit background on Celo. Celo is a blockchain that is built for the real world. And what I mean by that is a lot of our products interact with everyday users and users who are non-crypto native. So that's specifically what we try to focus on. We're a product chain. We like building products for non-crypto native everyday users. We were in layer 1, but we are actually transitioning to in layer 2 on the OP stack. We launched our Dango testnet about a month ago. So if you're interested in playing around and testing that out, feel free to join the super hack where we'll be interacting and playing around with our Dango testnet. We're specifically built for ease of use. So a lot of the features that make Celo special, such as sending transactions via phone numbers, such as really low gas fees, such as fee abstraction, and another plethora of things, is specifically because we want Celo to be super, super easy to use, super low latency, and you can use it on your phone. So you can interact with a lot of our apps are mobile first, mobile focused, because what we found is that a lot of blockchain users, people who are using the blockchain, don't necessarily also have a computer. So we really focus on being mobile first. One of our largest apps is called MiniPay, and it's natively integrated into the Opera Mini browser. What makes that special is that you can interact with our Celo blockchain straight on a browser with really low latency, which is exciting. And you can pay all your gas with any tokens, not just Celo, but with ETH, USD, CUSD, CUSDT, and other tokens like that as well, which is another fun feature about Celo. But we have a really huge ecosystem of a ton of projects that are interacting with the real world and solving everyday problems. And why this is really exciting is if you have other apps already and you want to interact with Celo's ecosystem, CCIP actually makes that possible. I think before CCIP, it really felt like as an app developer, you're building on some siloed islands. So say you launch a project on Ethereum, but you have to choose between which chain do I launch on and just kind of stay committed to that chain. And you can only use the benefits of that one chain, which makes for really poor user experience and really contributes to fragmentation, which is just not the ethos of what we're trying to do. We're trying to scale Ethereum. We're trying to scale real world solutions. We're trying to scale products being built on blockchain. And in order for us to do that, we need to no longer have silo chains, no longer have fragmentation, and instead figure out how you can leverage the benefits of multiple ecosystems to design the best app possible. So what does this specifically mean for application development? When you're designing your apps, how can you now rethink about what is possible, knowing that you can talk and communicate between different chains? So already you probably talked about what's exciting about CCIP, where you can do different asset transfers, data, tokens, everything can be transferred between chains like Celo and other chains like Ethereum or other ones. But why I'm super excited is this completely improves your abilities for dApps. So you can leverage the strengths and benefits of different chains. What this specifically means for Celo is, say you're really excited about MiniPay. MiniPay has a distribution channel to over 100 million daily active blockchain users who are non-crypto native. So say that's something that with your app, you really want to tap into. You really want to tap into Celo's incredible distribution channel to users within these emerging markets. But you want them to interact with NFTs within the Ethereum ecosystem. Say Celo doesn't have that NFT ecosystem that you want to tap into, but Ethereum does. How can you design your app so that you can both tap into Celo's distribution channel while also tapping into Ethereum's thriving NFT ecosystem? That's a little bit of what we'll talk about today. So specifically, we created a sample demo that shows how you can enable cross-chain NFT minting between Ethereum and Celo. What this means for the end user is if the end user is on an app on Celo, say they're on the app on the MiniPay wallet, they can actually interact with Ethereum NFTs without ever leaving Celo. So they can still mint, they can own everything on Ethereum, even though they're only interacting or paying with Celo gas fees. So we're going to go ahead and jump into the code. Feel free to follow along here. This is at github.com, Celo.org, Celo CCIP workshop. It should also be in your Git book as well. Feel free to follow along in the README. How this works high level, I'll jump into it in a second. But as you probably already talked about today, you have the source minter and you have the destination contract. We actually made custom iterations of these contracts for this example. So here we have the source minter, which is on Celo Alpha Horus. This is our testnet. And source minter is the one that actually bundles up all the information that you're going to need for all the details for minting the NFT. And it sends it to the destination minter contract. And the destination minter takes that, receives that message, uses CCIP receiver, receives that message, and actually mints the NFT on that behalf. So a little overview, we'll have the source minter contract, the destination minter, and a simple Celo NFT minter. This is just the standard ERC 721, and this will also be on Alpha Horus. So let's go ahead and jump into the code. As you can see here, this is our source minter address, and all that it's doing is this is the one that facilitates the contract minting NFT using Chainlink's cross-chain interoperability protocol. And what's special about here is you can actually pay the fees and either link or native tokens. So this is Chainlink's token, and then native would be Celo. And this allows a user who is minting an NFT on Ethereum to pay with Link or Celo, which is kind of a little breakthrough with dApp development, which is very exciting with that. And this actually handles the sending and messages to the router. And then next, we'll have the destination minter. And similarly, this uses the receiver. This is, again, inherited from Chainlink's contracts. And what this will be doing is it'll actually receive the minting instruction and then call the NFT contract based off of those instructions. So here it's calling the Celo NFT contract. And then as you can see here, this is just a standard ERC 721 contract. All right. So we're going to jump into the code. Feel free to follow along here at github.com, Celo.org, CCIP workshop. What you're going to want to do is you're going to want to ensure that you have enough tokens in your wallet. So you're going to want to go to our Alpha Horus faucet, make sure that you have some Celo tokens. We also want to go to the Chainlink faucet and get some Link tokens. For this example, I already did that. So already have some of them, and you can only get it every, I think, 24 hours. So I already used my net. And then you also want to get some Sepolia tokens as well. So that's what you should have. And then you can, of course, follow the prerequisites, make sure that you have everything as well. And then we're going to actually start setting up our code. So the first thing that you'll do after you download, install all the dependencies, make your environment file variable where you have your address private key, Celoscan API, Etherscan API. These are optional, but can help for your development experience. The first step is you're going to deploy the following contracts. So this is going to be the source minter, the NFT, and the destination minter. And what you're going to do after you deploy these contracts, I'll go ahead and show that for you. So here I'm in packages, I'm in Hardhat, and going to deploy these contracts. essentially what I'm going to do is I'm going to update the addresses.txt to have the correct addresses from these new contracts. So this is the source minter, and this is the contract now for the source minter. And if you want to just double check, you can take that same contract and you can paste it in to your Alfajores, and you can see that this contract is now on Celo. So likewise, we're going to paste that contract in, and then you're going to paste that into the addresses.txt. Same thing. Now we're going to deploy our NFT contract. This is going to be on Sepolia. And then this will take a little bit because it's deploying on Sepolia. We'll have that. And now that's going to be your NFT contract. And then you can just double check by going to Sepolia and checking your contract address. And then the next thing we have here is we're going to update. So now the destination minter needs to know the NFT address. So we're going to go into our scripts, and these are all our scripts that actually deploy the contract. And we're going to update the NFT address to be here. And then the router address, that stays the same because this is on Celo. So I'm going to save that and then save that. So then now that we have the NFT contract there, we can just go ahead and run the deployment script. And this will give you the destination minter address as well. This is going to give you this contract right here. And these are old contracts I had from the first time I ran it, just to practice. All right, so now that you have the 3 contracts, the next thing that you're going to want to do is you're going to want to transfer ownership of the Celo NFT. Because as you can see within the 4th script right here, or within the Celo NFT, this is ownable, meaning that whoever deployed the contract is the one that can own the NFT. So we want to run another script so that we can transfer the ownership of the NFT. So we're going to update the new owner. We're going to update the Celo. We're going to update the Celo NFT address. And then we're going to update the new owner to be the destination minter. Right there. And then now that those are both updated, we can actually run that script as well. And this will be transferring ownership of the Celo NFT to the destination minter. While that's going in another file, I'm going to open up our front end. So by doing that, you just go into CD, Packages, React App, and you can open up the front end that's occurring. And a little bit of what that will look like is, so I ran this right before we did this. That's why I have one NFT already. But what you can see is here is my wallet address, and I have some Celo, and I have some Link. And as you can see, I'm only on Celo right now, but I want to mint an NFT on Sepolia. So while I'm interacting only on the Celo blockchain, how can I actually mint an NFT that is fully on another chain? That's what this UI allows for. So let's go back. So that NFT was just transferred. The final step is, so that's what all will happen from the developer background. So that's what the developer does. You can have that all set up. And then the user, the front end user who comes in, all they want to do is they want to mint an NFT on Sepolia from Alfajores, which is the Celo testnet. So what you'll do is the first thing that you want to ensure is that the source minter has the right payable tokens to actually process the transaction. So let's go here. Source minter is this contract, and we want to send them, send this contract. We want to send them, I'm going to send them 25 Link so that they have enough to actually make this NFT call. And now the source minter, which is going to be on Celo, on Alfajores, actually has tokens, and these are going to be Link tokens, to pay for the NFT minting. So they don't actually need to have Sepolia tokens to pay for NFT. For the NFT, they can just pay using Link, or they can pay using Celo as well. But for this demo, we're showing it using Link. And this will actually pay the fees for the CCIP transaction. And now what we're going to do is we're going to update all the variables within script 5 to actually do this. So this is going to be the source minter address. Source minter is here. We have the destination minter address, which is going to be our destination minter here. And then the destination chain selector, as you know, those are standard for already for Celo. So that will stay the same. And then the last thing you're going to want to do is you're going to actually want to run the minting script. Or if you're on the user, you can actually just press the mint to Sepolia, and that also runs the script. And so what that happens is we just minted an NFT from Alpha Juarez to Sepolia. And if you want to check that, you can go here, you can click on this hash and go straight to Celo. And as you can see, this entire transaction only happened on Celo. Additionally, you can double check this by going to CCIP Explorer and let's see. Yeah, you can double check this. And as you can see within this message details, the source chain was Celo, but the destination chain was Ethereum Sepolia. And so now we can update. Actually, this might take, so source finalized right here. It's going to take around 3 minutes to actually finalize, but I can show you a past one if that helps. Here's an example of a past, the one I just did, if you want to check that this specific NFT transaction from the last one. From the one that I currently own, it is, as you can see here, this is already successful. So this shows my past NFT. This one will take a few minutes to finalize. It should take around 3 minutes, and then the front end should update saying that I now own 2 NFTs. And as you can see, I used to have 35 link token, but now I only have 10 link token. And I paid fully with this only using Celo, even though the NFT is on Sepolia. So if you want to also double check, we can go to our addresses. We can click on our NFT that's on and go into Sepolia and be like, oh, look, here is our, yeah, you can go ahead and check on the actual address. And then, wait, that's a transaction hash. Let's do this. And then you can read the contract and see who is the owner. So I'm going to say, do I own one of this? Double click it here. Oh, it's not fully, let's see, has it? So it's not fully finalized, but I'll do the same thing for this one. So you can see who's the owner of this wallet address, and then you can see that the balance should be 1. And once this is fully finalized, the Celo NFT, you can double check by seeing if you're an owner, and this balance count will be 1 once the source address is, once this contract is fully finalized. And that's it. It's really simple, but why this is really exciting, it means that the end user was only fully, the end user here was fully just interacting with Celo, but actually had the ability to mint NFTs on a whole nother chain. So this completely opens up what's possible. I definitely encourage you to fork this repository and see if you can do this with maybe not just Ethereum, but with another chain, and what this means for how you can interact and open up a whole new plethora of ideas for your products, for your apps, of what's possible now that you can build cross-chain interoperable apps. And you'll be pioneering app development within this field and within these types. So super, super exciting. Definitely reach out to me if there's anything. Let's see, I'm gonna go back here. If you have any questions, and I would love to know what you continue building. So feel free to reach out to me via Twitter or Farcaster. All of my information is in the Git book. And that's all for me.
Cool. Thank you very much, Sophia. That was really fun.
Awesome. Super glad you're here.
Yeah, thank you for joining us. This is right here somewhere is the URL to Sophia's Twitter, so you can follow her there. ask any follow-up questions. Also, all details about her socials and the socials from the Celo team is available in the Gitbook. And this kind of wraps up the day 2 of our CCIP Bootcamp. Thank you for joining us. Tomorrow, we're going to talk about CCIP DeFi with USDC and other stuff. Darby will be your host. Make sure to rest well. And again, deadline for homeworks is August 25th. If you have any follow-up questions, you can ping us on dedicated channel on Discord, or just tag us on Twitter, like myself, Richard, Zubin, Darby. We're here to help. So thank you, and see you tomorrow. Bye-bye.